So we need to simplify the given trigonometric expression. So let us begin. Now clearly in the numerator we have 4 cosine functions. And they are all added to each other. Now there is a transformation formula which states that if we have the sum of 2 cosine functions, then it's going to transform as a product of 2 cosine functions. So let me state the formula. Well, here we have cosine of alpha added to cosine of beta, so that transforms as a product of 2 cosine function. Similarly, we have the sum of 2 sine function, which transforms as a product of a sine and a cosine. We can apply that formula to the denominator part where we have the summation of 4 sine function. So what we'll do, we're going to add 2 cosine function at a time in the numerator, and in the denominator also we're going to add 2 sine function at a time. So what we'll do, let us first add the first term and the second term. Then we will add the third and the fourth term. Similarly, for the new denominator part, we'll add the first term and the second term, and then we'll add the third and the fourth term. So cosine of a plus b plus c plus cosine of negative a plus b plus c. If we're going to use this transformation formula, so we're going to get 2 times cosine of angle. So we'll have to add a plus b plus c with negative a plus b plus c, and then divide by 2. So that's a very simple exercise. So this is going to be b plus c multiplied to cosine of angle. So we'll have to take the difference. So the difference is going to be 2a over 2, or simply a. Fine. Now coming to the summation of the third and the fourth term, we're going to get 2 times cosine of angle. So first we're going to add the 2 angle. So this is going to be 2a over 2, which is simply cosine of angle a, multiplied to cosine of the difference of the angle a minus b plus c minus a plus b minus c. So that is going to be equals to negative b plus c, divided by, now we will work with the first 2 terms in the denominator. So we'll use the transformation formula for the sum of 2 sine functions. So here we will have 2 times sine of the angle. So first we'll have to add a plus b plus c with negative a plus b plus c. So that's going to give us b plus c, multiplied to cosine of angle. So the difference is simply going to be equals to a. Then added to, so we have sine of a minus b plus c minus sine of a plus b plus c. So here, if we have sine of alpha minus sine of beta, then this formula is then going to be 2 times cosine of alpha plus beta over 2 multiplied to sine of angle alpha minus beta over 2. Right. So we'll employ this particular formula. Now we will have 2 times cosine of angle. So first we'll need to add alpha and beta. So a minus b plus c added to a plus b minus c. So this is going to be 2a. So 2a divided by 2 is simply going to be a. Then we have sine of angle. So we'll have to subtract a plus b minus c from a minus b plus c. So that's going to leave us with negative b plus c. Fine. So we will now have 2 times cosine of angle b plus c multiplied to cosine of angle a plus 2 times cosine of angle a. But we know that cosine is an even function. Because it's an even function, so cosine of negative b plus c, but this can be also expressed as cosine of, so we can take negative as the common factor, negative of b minus c. So this negative sign is going to become positive, so we'll have cosine of positive b minus c. You can say that cosine of negative b plus c is going to be equivalent of cosine of b minus c, whereas sine is an odd function. So that means sine of negative b plus c, so this will become negative times sine of angle b minus c. Fine. So let's use this. Now cosine will be b minus c all divided by, we have 2 times sine of angle b plus c multiplied to cosine of angle a plus, so this is going to be negative. So we have negative times 2 times cosine of angle a multiplied to sine of angle b minus c. So what we'll do now, we will take 2 cosine a as the common factor in the numerator. So 2 times cosine of a, so this will be multiplied to cosine of angle b plus c plus cosine of angle b minus c. Fine. Divided by, we have 2 times, we also take 2 times cosine of a as a common factor in the denominator as well. So we have, that's multiplied to sine of angle b plus c minus sine of angle b minus c. Fine. So 2 times cosine e will be factored out. Now what we are left with is the sum of two cosine function in the numerator, cosine of b plus c times cosine of b minus c, and then we have difference of two sine functions in the denominator. So we have sine of b plus c minus sine of b minus c. So what we'll do, we'll again apply the transformation formula. So in the numerator, we're going to get 2 times, it will be the product of two cosine functions, since we are doing the sum of two cosine functions. So we have 2 times cosine of b plus c added to b minus c. So that's 2b. 2b over 2 is simply going to be b. Multiplied to cosine of, so b plus c minus of b minus c. So that's going to leave us with simply c. Whole divided by, now we have difference of two sine functions. So we have 2 times cosine of angle b times sine of angle c. So here 2 times cosine of b will get factored out from the numerator and the denominator. We are left with the ratio cosine c over sine c. So that's nothing but the cotangent function. So we get cotangent of c. So this has defined the answer, and hence we have successfully showed that the simplified value of the given trigonometric expression, so this is going to be equals to cotangent of c.